Good afternoon, everyone. My name is Ahmad Abdul Basit from NTIC Abuja Boys. I stand before you today, carry out some questions and answer session with you, solving past questions from JAMB 2020. Without wasting much time, let's dive in. So the first question here. A few grains of table salt were put in a cup of cold water, kept at constant temperature and left undisturbed. Eventually, all the water tasted salty. This action is due to A. Convection, B. Osmosis, C. Capillarity, and D. Diffusion. Now, looking at this question, the best likely answer here will be either osmosis or diffusion, but then one of them is wrong while the other one is correct. Now, let's take osmosis, for example. Osmosis simply involves the movement of molecules from a region of lower concentration to a region of high concentration, while diffusion, on the other hand, involves the movement of molecules from a region of high concentration to a region of low concentration. So the correct answer to this question is diffusion. Let's move on to the next question. The next question says, a constant force of 40 Newton acting on a body initially at rest gives an acceleration of 0.1 meters per second squared for 4 seconds. Calculate the work done by the force. Now, before we dive into this question, we need to first sort out the information given to us. We need to find the data. So let's take the data out. Start by saying data. Okay, let me change the color of the ink. Let's pick white. So we start by saying data. A constant force of 40 Newton. Now we are given the force. F is equal to 40 Newton. Acting on a body initially at rest tells us U is 0. Gives an acceleration of 0.1 meters per second squared. The acceleration is given to us as 0.1 meters per second squared. For 4 seconds, the time is known, 4 seconds. Calculate the work done by the force. Now, work done is not given, and we have to look for it. Before you start anything, you need to recall the formula for work done. Work done, as we all know, is given by what? Force times distance. Force times distance. But then, in the question, we have the force clearly stated, but the distance is not given. We need to look for distance. How do we do that? We go back to the equations of what? Motion. Which equation would be best suited for finding distance in this case? Let's see. S equals ut plus half at squared. Here the distance is represented. U, which is the initial velocity, is also represented. The time is represented. And A, which is acceleration, is also represented. But remember, we're told that the body was initially at rest. So therefore, U is 0, thereby making ut 0. So we start by saying S equals 0 plus half. A is given to us as 0.1 times T, which is 4 squared. Here we take this as half times 0.1 times 16. We are going to make use of our calculator. So if you have your calculator, you grab it. So let's do the math together. 2 will go here, 1. 2 here, we have 8. So we are left with 0.1 times 8, which will give us 0.8. S is known as 0.8 meters, but that is not the end. Let's continue. Let's see now. We have our distance. We bring it back into our original equation, which is for work done. Work done equals force, which is given as 40, times distance, which is 0.8. So 40 times 0.8. You can go ahead and use your calculator if you wish. You can just take this as 8 over 10. 0 will go with 0. You have 4 times 8. And what is 4 times 8? 4 times 8 will give us 32. We are looking for work done. The SI unit of work done is joules. So the correct answer here is C. Let's move on to the next question. Okay. The next question is, which of the following is a derived unit? Which of the following is a derived unit? We already know the fundamental units, but then the derived units are gotten from simple combination of what? Fundamental units. In this case, looking at kilogram, which is option A, kilogram is the unit of mass, which is a fundamental unit, by the way. Meter is the unit of distance or length, which is also a fundamental unit. Kelvin, the unit of temperature, is also a fundamental unit. But then Newton is the unit of force, unit of weight, which is a derived unit, because you get the unit Newton by simply combining the the unit of mass and acceleration. So therefore, in this question, D is our correct answer. Let's move to the next question. An electric heater is used to melt a block of ice of mass 1.5 kg. If the heater is powered by a 12-volt battery and a current of 20 amps flows through the coil, calculate the time taken to melt the block of ice at 0 degrees Celsius. Take the latent heat of fusion of ice to be equal to 336 times 10 to the power of 3 joules per kilogram. Now, looking at this question, just as we did in our previous question, we tried to bring out the data. Okay, let's go dive into it. Data. Now, in this question, we'll read again. An electric heater is used to melt a block of ice of mass 1.5. Mass is given to us as 1.5 kg. If the heater is powered by a 12-volt battery, V is given as 12 volt. And a current of 20 amps, current 20 ampere, flows through the coil. Calculate the time taken. We are looking for the time. Time is unknown. To melt the block of ice at 0. Theta is given to us as 0 degrees Celsius. But then we have the latent heat of fusion of ice, which is 336 times 10 to the power of 3. Now, the equation that will combine everything we have on the board together will be that of Q equals H. So in this case, we have ml equals IVT. Mass is given to us as 1.5. L is given to us as 336 times 10 to the power of 3, which is equal to, I is known as 20. 20 times V is given to us as 12, while T is what we are looking for. T is unknown. You can decide to just make T a formula directly by saying T is equal to 1.5 times 336 times 10 to the power of 3 all over 20 times 12. When you do this using your calculator, you are going to have 1.5 times 336 exponential 3. We have 504,000 all over 20 times 12. 20 times 12. We have our final answer will give us 2100. 2100. That is 240 here. So time is calculated now. We have our answer in seconds. But then looking at the options we have here, the answers are represented in minutes. So how do we convert 2100 seconds to minutes? We simply do that by dividing it by what? By 60. So 2100 divided by 60 gives us 35 minutes. So we'll convert this by saying 2100 divided by 60, which will be equal to 35 minutes. So 35 minutes, meaning option B is correct. Okay, let's move to the next question. Okay, next question. Here we have a table given to us. We are to work using this table now. Which of the following instruments consumes the highest current? Which of the following instruments consume the what? Highest current? You can take your time. Try to see if you can actually get your answer directly from here. Okay, although we are still going to solve. So let's take the first one, electric iron. Now looking at this, they said we should find that of the highest current. Here we are given the voltage, we are given the power. Let's take them one after the other. For option A, we have V. We have V to be equal to 150 volts. And then the power is giving us 1 kilowatt. As you know, we cannot use power as 1 kilowatt. We need to convert it to watts. We simply is 1 times 1,000 to give us 1,000 watts. Okay, so we have to look for current in this case now. P is equal to IV. This is the equation that relates them. So P is equal to IV. In this case, I is unknown. I is unknown, so we make I subject of formula and then take P over V. We work with this formula in solving the other questions. So power is given to us as 1,000 all over V, which is 150. So we go back to our calculator, 1,000 divided by 150. Okay, here we have 6.67 amps. Okay, 6.67. Let's just write it somewhere, 6.67. 6.67. That's for the option A. Now for option B, let's try to see. We are going to pick the power and use this formula as stated. Okay. Option B. Remember, we are taking this formula, we are using this formula P over V. So therefore, we are taking 110 divided by 220, which is 110 divided by 220. Let's go back again and check 110 divided by 220. This will give us 0.5, 0.5. So option B, we have 0.5. The third one, we have 30 over 6. So we are going to erase this also. Do the same for the third one. So in this case, P is given to us as 30, while V is 6. 30 divided by 6 will give us 5 ampere. So we have 5 for option C. Now for the last one, which is 500 and then 110. 500 and 110. So let's see. Okay, so here we have 500 as the power given, and then 110 as the voltage. 110. So let's go back to our calculator. 500 divided by 110, which will give us 4.5. 4.55. So we have 4.55. Now go back to the question. We were asked that which of the following instruments consumes the highest current? As you can see, the highest value here is 6.67. So the correct answer for this particular question will be option A. The electric iron consumes more current. Okay, let's move on to the next question. Our next question is this. So in this case, we have a circuit. And in our circuit, we are given 3 resistances, and then we have our current, which is 2 ampere, and then we have our voltage, which is given as 12 volts. So first, we need to look for the total resistance. We need to look for the total resistance. In this case, we start by saying V is equal to IR, using Ohm's law. V equals IR. So here we are going to have 12 equals, current is given as 2, and then overall resistance, which is total resistance, RT, is unknown. So in this case, RT is equal to 12 all over 2, which will give us 6 ohms. This is our RT. We are going to write it somewhere here. Okay, we'll come back to it, given to us as 6 ohms. Now let's go back and try to solve for others. So here we need to look for the equivalent resistance in this case. We need to look for the equivalent resistance in this case. We erase this, and then after looking for the total resistance, which is 6 ohms, we are going to move on to talk about the resistors arranged in both series and in parallel. So we are going to pick the connection in parallel, which is R and 6 ohms. Okay, so in this case, we need to find the equivalent resistance. Okay, so which we are going to do by saying 1 over R equivalent, or let's call it Rx, R subscript X, equals 1 over R plus 1 over 6. Okay, R equivalent, which is Rx, is what we are looking for. Then R here is the unknown resistance here. And then we have R over 6, which is the value of this resistor. Okay, the resistance of this resistor. So basically from here, we can look for the LCM of R and 6, which will give us 6R. R into that, we have 6. And the other side, we have R. So remember, we have Rx on this side. This is 6 plus R over 6R. So therefore, Rx will be given to us as 6R over 6 plus R. Now, we are going to take this also and keep it aside because we are going to need it. Rx equals 6R over 6 plus R. So, let's go back. Now we've considered the resistor in parallel. Now we are about to take resistors in series. The resistors in series. So it means everything here is Rx, which is equal to 6R over 6 plus R. Now, in order to find the resistance in series, we are going to take R total is given as 6, as we have it up there. So we are simply going to say RT is equal to 3 plus Rx. RT is 6. This is equal to 3 plus, what do we have? 6R over 6 plus R. Okay, let's take the LCM of this, and that will give us 6 equals, here we have 6 plus R. We have 3 into 6 plus R plus 6R. So over here, we can just move on to say this is 18 plus 3R plus 6R all over 6 plus R equals 6. We can simply take like terms here. When we sum up this and that, we are going to have 9R. So we have 18 plus 9R over 6 plus R equals 6. So let's move to a new slide so we'll get enough space. So we can have enough space. Okay, so from here, we are simply concerned with this value, this value, this value. So for that reason, I can conveniently erase everything else in order to get space. Okay. So therefore, let's continue. Now we have 6 equals 18 plus 9R all over 6 plus R. We cross multiply by saying 6 into 6 plus R equals 18 plus 9R. Let's expand the bracket and then collect like terms. We have 36 plus 6R equals 18 plus 9R. By collecting like terms in this case, we are transferring 18 to the left-hand side and taking 6R to the right-hand side. So we have 36 minus 18 equals 9R minus 6R. So here we have 18 equals 3R. In order to find R, we need to divide both sides by 3. So we have 3, and R will be equal to 6 ohms. So let's go back to C. In this case, it means our correct answer is B, which is 6. So, without wasting much time, let's move on. Next question. We have a question on machines. So here we have a pulley system. Remember, when dealing with a pulley system, Your VR, which is the velocity ratio, is simply the number of pulleys that you have. So basically here, we can bring out the data easily by saying data. The figure represents a block and tackle pulley system on which an effort of W newtons supports a load of 120 newtons. If the efficiency of the machine is 40%, then the value of W is, we don't know. As you can see, down here we have 120 newton, which is going to serve as our load. So we require an effort of W newton in order to lift this load. So therefore, the load is given to us as 120 newton, but the effort is unknown. Efficiency is given to us from the question as 40%. What else do we have? What else do we have? Okay, we have everything we need. So, like I mentioned earlier, in order to get the velocity ratio, all we need to do is count the number of pulleys. So here, our velocity ratio is simply 1, 2, 3, 4, 5, 6, which is 6. Okay, we have 6 pulleys, so our velocity ratio is 6. Now, let's go back. What equation do we need? Efficiency equals mechanical advantage all over velocity ratio times 100. We'll be using this equation to solve. Remember, mechanical advantage is simply given by the formula load over effort. Load over effort. So efficiency here is given as 40. Mechanical advantage is load over effort. So we are going to break down this formula by taking load as 120 all over effort, which is unknown, divided by velocity ratio, which is 6 times 100 all over 1. To get rid of the division sign, we need to what? Introduce a multiplication sign, thereby switching the 6. So this is 40 equals 120 over E times 1 over 6 times 100 all over 1. Over here, all we need to do is multiply the numerators and then multiply the denominators and then cross multiply. Now by so doing, we are going to have 120 times 1 times 100, which will give us 12000 all over 6 times E will give us 6E. But remember, we have to cross multiply. So let's use another slide. Let's use another slide for that. Okay, so here we have 12,000 all over 6E. So I'm going to continue on this side. I'm going to continue on this side. So we have 40 equals 12,000 all over 6E. Remember, we are cross multiplying. So this is going to be 12,000 equals 40 times 6E. 12,000 equals 40 times 6E. So let's go back to our calculator. 40 times 6. We have 240E. This is 240E equals 12,000. So 240E divided by 240 equals 12,000 divided by 240. This goes with that. And we have to divide the 12,000 now by 240 in order to get the value of E. 12,000 divided by 240 will give us E to be equal to 50 Newton. Let's see. Do we have 50 in the options? In the list of options, we have 50 as option D. So option D is the correct answer. Okay, without wasting time, let's move on to another interesting question. Okay, so in this question, we have a ship traveling towards a cliff receives the echo of its whistle after 3.5 seconds. A short while later, it receives the echo after 2.5 seconds. If the speed of sound in air under the prevailing conditions is 250 meters per second, how much closer is the ship to the cliff? Remember, when dealing with echoes, an echo is the sound that you hear after the sound produced has gone through a distance and then back to you, gets reflected back to you. So it has traveled twice a particular distance. So in order to solve questions on echo, all you need is to remember your formula for velocity which is simply V equals X over T. But then, remember we said, in this case, the sound must have traveled twice the distance. So we have 2x all over time. This is the difference between the formula for speed and then that of echo when dealing with echoes. So let's take the first case. The sound was heard 3.5 seconds later. The second case, 2.5 seconds later. So T1 will be 3.5 seconds, while T2 will be 2.5 seconds. Let's swap for 3.5 seconds. V, which is 250, V is given as 250 meters per second. So V, which is 250, equals 2x over time, which is 3.5. So in order to get x, we need to first cross multiply and then divide both sides by the coefficient of x, which is 2. So 2x will be equal to 250 times 3.5. Okay. We divide both sides by 2, divide both sides by 2. So let's go back to our calculator now. 250 times 3.5. We have 875 divided by 2, which will give us 437.5. Remember, we are calculating distance, that is in meters. We are going to use the same formula. This time around, we are going to use time as 2.5, not 3.5 anymore. So let's look at it. Second case, we have the same formula now. The same formula, we have 250 equals 2x over time, which is 2.5. So I won't want to go through the entire process. I just cross multiply and do the needful here. So x will be equal to 250 times 2.5 all over 2. So here we have 250 times 2.5. We have 625 divided by 2. And that will give us 312.5. Now, in order for you to get how much closer the ship is to the cliff, all you need to do is you subtract the second value, that is for T2, from the first value of what? T1. So all we need to do here, we say x is equal to 437.5 minus 312.5. So what do we have here? 437.5 minus 312.5. This will give us 125 meters. Do we have 125? Ah, we do. D is the correct answer. D is equal to 125. So, yes, let's move on to the next question. Okay. For the next question, we have a question on expansivity. Okay. The linear expansivity of brass is 2.0 times 10 to the power of minus 5 degree per degree Celsius. If the volume of the piece of brass is 10 centimeter cube at 0 degrees Celsius, what will be its volume at 100 degrees Celsius? Okay, let's try bringing out the data given, the information given in the question. We'll start by saying solution. Data. We have the linear expansivity of brass given as that. So linear expansivity is given as 2.0 times 10 to the power of minus 5. Okay, per degree Celsius. Okay, what next? If the volume of a piece of brass is 10 centimeter cube, volume V1 is given as 10 cm cube. At what? Theta 1 is 0 degrees Celsius. Theta 2 is 100 degrees Celsius. But V2 is unknown, and we are asked to look for it. What will be its volume at 100 degrees Celsius? So, now here, there's something very important to note. We are given the linear expansivity, but every other thing is for volume expansivity. All you need to do here is you need to remember the simple relationship that volume expansivity is 3 times the linear expansivity. Volume expansivity is 3 times the linear expansivity. So therefore, volume expansivity is 3 times 2.0 times 10 to the power of minus 5. Okay, from here directly we have 6 times 10 to the power of minus 5. The unit remains the same. So therefore, in order to look for the V2, what we need to do is, remember, volume expansivity equals change in V over V1 change in theta, difference in temperature. So here we have 6 times 10 to the power of minus 5, change in volume unknown. Then we look for our V1 from here, which is 10. And then times change in temperature is simply 100 minus 0, which is 100. Okay, so from here we can just cross multiply directly. We cross multiply. So over here we have 6 times 10 to the power of minus 5 times 10 to the power of 3 equals change in volume. Okay, so this will give us 6 times 10 to the power of minus 2. 6 times 10 to the power of minus 2 cm cube. Okay, this is for the change in volume, but that's not the end. They didn't ask us to look for change in volume and then stop there. They want us to look for the final volume at 100 degrees Celsius. So we have this value. We keep this at the back of our minds, and then let's go to, let's create some space. Let's create some space. I can take away this. I can take this. I think I can take this too. I can take this too, in order to have enough space. So, remember, we looked for change in volume. So therefore, change in volume is simply equal to V2 minus V1. That is the difference between the volumes. So therefore, here we have 6 times 10 to the power of minus 2 equals, V2 is actually unknown, that's what we are looking for, minus V1, which is given to us in the question as 10. Okay, so we collect like terms. We have V2 to be equal to 0.06 plus 10, and this will give us 10.06 cm cube. Do we have that in the list of options? Yes, that's option A, which is also very much correct. So let's move on to the next question. Let's move on to the next question, which happens to be our last question for the day. Our last question for the day. Okay. So here, we are dealing with temperature and its measurements. The lower and upper fixed points marked on a mercury in glass thermometer are 210 millimeters apart. The end of the mercury column in the tube is 49 millimeters above the lower fixed point in a room. What is the temperature of the room in degrees Celsius? So let's try to create a pictorial representation of what we are given here. Okay, we'll start by saying, okay, we're told that the lower and upper fixed point, meaning the fundamental interval is 210. So we'll take the upper part as 210 mm, assuming this is from 0. Okay, mm. Then we're told that the end of the mercury column in the tube is 49 mm above the lower fixed point. So let's take from here, 49 mm above should be somewhere here. Let's say 49 mm. Okay, now we are asked to look for the corresponding temperature in degrees. So we are going to draw our Celsius scale here, which is going to be 0 Celsius, upper fixed point of 100 degrees Celsius. Then somewhere here is where we have X. Okay, so quickly let's try to see how we can find X. Let's consider the left hand side first. Taking the midpoint minus the lower fixed point all over upper fixed point minus the lower fixed point, which is going to be 49 minus 0 all over 210 minus 0. We do the same for the right hand side, which is X minus 0 all over 100 minus 0. So here we have 49 over 210 equals X over 100. As before, all we need to do is try to make X subject of formula. How do we do that? We cross multiply this and then try to make X subject by dividing both sides by its coefficient. So now let me create some space for us, some working space here. Okay. So, yes. That's beautiful. Now let's see. From here we have 210x equals 49. This should give us 4900. 4900. Okay, we'll be working with these values. So let's take them up. 210x equals 4900 divided by 210 in order to make x subject of formula. 210. This goes with that. X is given to us as 4,900 divided by 210. 210. This will give us 23.3. 23.3 degrees Celsius. 23.3 degrees Celsius. Let's see, do we have that in the list of options? Yes, we do. Option C is the correct answer. And we've come to the end of the class for today. Thank you for watching. I am by name Ahmad Abdul Basit. Have a lovely day.